the Azure Internet of Things. And the agenda for today's webinar would be, so we would first discuss what Internet of Things exactly means, why it matters, how IoT in general works, why Azure is the platform of choice to go for IoT, the types of solutions that Azure has to offer. We'll discuss more on the solutions, and typically we'll focus on one of the solutions, which is the Azure IoT Central. Lastly, we'll have a small demo that will basically set up a custom template and display some telemetry data on a dashboard. So we'll be simulating a device. To start things off, let's start off with the age-old question: what exactly is Internet of Things? Now, if you go online, if you scroll through the internet, you will find a technical definition which reads something like, it's a system of interrelated computing devices. They might be mechanical, they might be digital machines, they might be objects, animals, or people, all of which are provided with unique identifiers, and they have the ability to transfer data over a network, thereby reducing your human-to-human or human-to-computer interaction. Now, if you look at it, this definition in general seems unnecessarily complex, and it seems too technical. So if someone's coming to seek some clarity, it leaves him all the more confused. So what's an even simpler explanation that can convey the idea better? It would be, say, take an example of cell phones. Everyone here must be remembering the older phones which had a keypad and it had a small screen. The primary purpose of your cell phone was to call and to text. Now the newer smartphones, they're also capable of all of the same technologies as the previous cell phones, but a lot more. You can read books on your phones, you can watch videos, you can listen to songs. There are countless amounts of things that you can achieve using your current gen smartphones. Now all of these benefits, they were unlocked after we connected our devices to the internet. Internet of Things is a simple concept. It's just made unnecessarily complex. It's taking all of your devices, all the things, and you're connecting them to the internet. So moving on, why IoT matters. Say when something is connected to the internet, it means that that particular thing can send information and it can receive information, and or it can do both. Now the ability to send and receive information makes things smart. Going back to the example of smartphones. So right now you can listen to any song that you want to in the world. Because why is that? Does your phone actually have each and every song in the world stored on it? No, it's because the song is stored somewhere and your phone has the access. It can send the information, it can ask for that particular song, and it will receive, thereby streaming the song on your phone. Now to be smart, your phone doesn't need to have super storage or it doesn't need to have supercomputer capabilities. All it needs to have is a simple connection to a storage or a computer. Now in Internet of Things, there are three categories that we can categorize the device into. First thing is things that collect information and send it. Then there are things that receive information and then they act on it. And then there are things that do both. Now things that collect information and send it might be your sensors. They can be your temperature sensors, they can be your motion sensors, they can be moisture, air quality, any of the sensors. A sensor with a connection will allow you to collect information from the environment in which it is placed, thereby making intelligent decisions. Now, say an example of a farming scenario. You have a sensor which automatically gets information about the soil moisture. It can tell the farmers exactly when the crop needs to be watered. Instead of watering too much or watering too little, the farmer can ensure that the crops are getting exactly the right amount of water. Now, things that receive information and act on it, we have been interacting with such things for quite some time now. Take, for example, your printer. Your printer receives a document and it prints it. Your car, say you want to unlock it, it receives a signal from your car keys and the doors open. Whether it's as simple as sending the command to turn on, or it's as complex as you're sending an entire 3D model to a 3D printer, you can tell machines to do from far away. Now there are things that do both. The real power of Internet of Things arises when things can do both. Things that collect information and send it, but they also receive the information and then they can act on it. Take a completely constrained agricultural example. The sensors will collect the information about the soil moisture. They will tell the farmer how much to water the crops, so you don't actually need the farmer. The irrigation system can automatically turn on as needed based on the moisture in the soil. If the irrigation system is even more smart, if it receives information about the weather, it can also know when it's going to rain, and it can then decide not to water the crops that particular day because they will be watered by the rain anyway. Now, all this information, the soil moisture, the irrigation system watering the crops, and how well the crops actually grow can be collected. They can be sent to computers, which will run some kind of algorithms, some kind of analytics on them, and we can make sense of this information. This is just with one kind of sensor. Add in a couple more and we'll have a very intelligent solution. Now, how IoT exactly works? An IoT ecosystem consists of web-enabled smart devices. They use processors, sensors, and communication hardware, wherein you collect, you send, and act on the data that you acquire from the environment. IoT solutions require secure bidirectional communication between devices, and your devices can be numbered in the millions. You also need a solution backend. Your IoT devices will collect the data, it will send it to a cloud gateway. The cloud gateway will make the data available for processing by other backend services. Sometimes these devices will communicate with other devices and they will act on the information that they receive from one another. The devices are doing most of this work without human intervention. Although people can interact with the devices to set them up, give them instructions, or accessing the data. Now, in an IoT solution architecture, devices typically send telemetry data to the cloud for storage and processing. Say we take another example. In this example, we have a kind of a predictive scenario in which your solution backend is using the sensor data, and you have a field of pumps in which one specific pump requires maintenance. Your devices will receive and respond to the cloud messages by reading the messages, and the solution backend will just send the message to other pumps. Say a particular pump is requiring maintenance, so it will send the message to other pumps in the pumping station, and it will reroute the flow just before the maintenance on that specific pump is about to start. Connecting devices securely and reliably is one of the bigger challenges in IoT. This is because IoT devices, they have different characteristics as compared to your browsers, your mobile apps, to other clients. In modern IoT solutions, data processing and analytics occur in the cloud or on the device side. Device-side processing is referred to as edge computing. The choice of where to process the data typically depends on how strong your network is. if your bandwidth between the devices and the cloud is limited, it would be more, there is more incentive if you select edge processing. Similarly, if there is a requirement to act on a device in real time, it is better to process the response in the device itself. And then there is a constraint that some of the data that you have, it just cannot be sent to the cloud. Then there is the third part, which is the presentation and the business connectivity. The presentation and business layer allows users to interact with your IoT solution and your devices. It will enable your users to view and analyze the data collected from their devices. They can take all of this data, they can form dashboards or BI reports, and you can display both your historical as well as your real-time data. Say you have an operator, he can check on the status of the pumping station and he can see if there are any alerts raised by the system. Moving on, why Azure is the platform of choice for implementing IoT. Now, Azure IoT simplifies the complexity of IoT projects and it addresses the challenges such as security, whether your infrastructure is compatible or not, as well as scaling your IoT solution. So here we can see three particular aspects. The first one being agile. You can start off small with Azure. You can grow to any size, anywhere and everywhere. You might have millions of devices, you might have terabytes of data, and all of this will be available in most of the regions worldwide. Azure is open, so you use what you have and you can connect to any device, software as well as service. Hybrid, so you build according to your needs, wherein you can deploy your IoT solution at the edge, you can deploy it in the cloud, or you can deploy it intermediary in between the two. Lastly, we have something such as the pace, so you deploy faster, you have the speed, you speed up the time to market and you stay ahead of your competition. The second aspect, comprehensive. Basically, Microsoft is the only IoT solution provider which has a complete platform with access to big data, advanced analytics, managed services. IoT being all about data, the best IoT solutions bring together all of the tools that you need so that you can store, interpret, transform, analyze the data. And you can present it in the right way so that the end user can understand. And IoT in Microsoft is device centric. So it allows you to connect anything, be it a legacy equipment or be it one of the current vast ecosystems of hardware, and build your own devices across edge, mobile or embedded systems. The last part that we'll be targeting is security. So Azure solves the hardest part about IoT, and that is security. So you bring together your vision, your technology, the best practices and capabilities, and you can solve the hardest part of IoT. You can even secure your data with identity and access management, threat protection and security management. You can ensure the safety of your data across devices, softwares, and cloud services, be it on-prem. Lastly, we have something compliance, wherein Microsoft is the leading standard in establishing security requirements, be it for international borders or be it for industry-specific standards for IoT data and services. Have a look at the types of solutions that Azure has to offer. Now, Microsoft has built a portfolio that supports the need of all of its customers. It enables everyone to be a part of this digital transformation. Now, there are two paths that are available for building a solution. The first one, as you can see, is the platform as a service. So Azure has the solution accelerators. These are customizable PaaS solutions, and they provide a high level of control over your IoT application. If your business is implementing IoT for connected operations, or say it has specific customization requirements, solution accelerators are the way to go. Organizations with a large number of devices, tons of device models, and manufacturers seeking a complete connected factory solution are examples of companies that will benefit from your Azure IoT Solution Accelerator. Creating a highly customizable solution tailored for complex needs, it also provides pre-built solutions wherein you can handle remote monitoring, you have a connected factory, be it predictive maintenance, or you want to simulate a device. The second offering is software as a service, wherein you have Azure IoT Central. Azure IoT Central is a complete, fully managed SaaS solution. It allows you to get started with minimal to no IoT experience. If your organization lacks the resources to build your own IoT solution, Azure IoT Central is a codeless IoT solution that can create device models, dashboards, and rules in minutes. Organizations with few device models, more predictable scenarios, and limited capabilities can benefit through this SaaS approach. We'll be focusing a little more on the Azure IoT Central. Now, Azure IoT Central, as I mentioned, it's a fully managed software as a service solution, and it makes it easy to create projects or products that connect the physical and the digital world. As compared to a typical IoT project, it will take the hassle out of managing an IoT solution. So you're reducing your management burden, you're reducing your operational costs as well as your overheads, and you're making it easy so that you can customize your application. You are also integrating industry-leading technologies such as the Azure IoT Hub and the Insights, as well as end-to-end encryption. There are a few considerations before starting off on an Azure IoT Central project. So the four main aspects to consider while setting up an Azure IoT Central application would be: first is deciding the personnel who interact with your IoT Central application. So we typically have 4 roles who would interact with the IoT Central application. One of them would be the builder, who would be responsible for actually defining the type of devices that connect to the application and customizing the application for the operator to use. Second would be an operator who manages the devices that are connected to the application. A third role would be that of an administrator. So he is responsible for administrative tasks such as managing your users, your roles within the application. And last one would be a device developer who would create the code that would run on your device, which is connected to the application. Second consideration would be creating the application. Now, as a builder, you would use custom cloud-hosted templates for the organization, or you can deploy a new application and then customize it as per your specific requirements right in your web browser. You can use the web tools and you can create a device template that connect to your application. A device template is nothing but it's a blueprint of a device model. All the devices created from the same template share the template. And a device template is nothing but it will define the characteristics, the behaviors of the devices that it connects to, it will record the telemetry, it will showcase the business properties that the operator will then modify, as well as some device properties which are read-only. The third part would be connecting the devices. After the builder defines the type of devices that connect to the application, your developer will create the code that will run on the devices. As a device developer, Microsoft offers IoT SDKs that you can create your device code on. The SDKs have broad language, platform, and protocol support, so they can meet each and every need. Lastly, we have managing the application. Now, Azure IoT Central is fully hosted by Microsoft, so there is no administration overhead for managing the application. You can manage your devices so that the operator can perform tasks such as monitoring the devices, troubleshooting and remediating any issues that they face with the devices, or provisioning new devices. Now let's follow up this discussion by going through a small demo for the IoT Central application that I've set up in Azure. So this is the IoT Central portal that Azure offers. Currently, I'm on a trial version. So if you go to the particular URL and create a new IoT Central application, it offers two options. One is starting a free trial of 7 days, or else subscribing to the pay-as-you-go model and working around in the environment. So I have already created a device template, but the ideal way to do it is you create a new device template. You enter a name for the template, and then it will ask you whether you want to use one of the sample templates that Azure has to offer, whether you want to create a custom one right from scratch so that you can define all of the properties, settings, rules, everything. So I have already done that, wherein I have created an air conditioner to be a simulated device. So the whole idea of creating a test application is, before you connect your real device, your Azure IoT Central will help you generate telemetry data from the device template so that you have an overall idea of how the device should function. So going to the connected air conditioner, we have separate tabs wherein we can send the telemetry data. We can display the telemetry data, which is the temperature, be it the humidity. We can have states wherein we can show whether the device is on or whether it's off. We can have static read-only properties like the firmware version, the serial number, display, as well as you can set a target temperature. So the operator can send out a request wherein he can set the target temperature at which the device should be operating. So right now we are on the measurements page. So measurements page, we can create the telemetry data. So right now over here, I have created a temperature chart. It shows me the average and it's real time. So it's tracking the information as I'm speaking to you right now. It is simulating a connected air conditioner. It's very simple to add telemetry data. So you just click on the edit template, you click on the new measurement, and you get options wherein you can select whether you want a telemetry data, whether you want state and event. So right now I've created a temperature telemetry data, which the yellow line graph is actually the telemetry data. Similarly, we have the states, which are nothing but they show you the state of the event or the component over time. So I can show when the fan in the air conditioner was turned off. The blue denotes when the fan was in operating mode, and clicking on it, actually it time slices it and showcases the data. And then you have a scenario wherein, such as an event, which is used to track if a particular error or something erroneous or some anomalous behavior has happened in this particular event. So they define point in time data, and it signifies something like, say, a component has failed. So these red tiles are dummy data that is created by the Azure IoT Central, just to give an idea of how the entire portal would look in case an event like this occurs. So if I click on the tile, it will show me when that particular error occurred and at what time. Moving on, we have settings, we have properties. In settings, you can send configuration data to your device from your application. This is typically what an operator does. He will send the data. An operator will also be able to change, say, a telemetry interval. Say you're recording for 5 seconds, you can change that interval to something like 10 seconds. The device will acknowledge the change and then it will respond back with a sync message. Similarly, you have properties. Now, properties are metadata that is associated to the device. They record information about your application. So you can use your application properties. You can display your device location. You can say when it was last serviced, all of these. Your firmware version and service number are actually read-only properties which are sent by the device back to the operator. Next, you have commands. Commands are basically something which allow the operator to run directly on the device. And lastly, we have the dashboard. The dashboard is nothing but so the entire air conditioner template that I've just configured. So you can customize your dashboard so that you can include just the measurements, settings, properties that are of importance to you as an operator. So right now we can see that we have a line chart over here, which is recording data from the past 30 minutes. We have all the events that are listed that goes on for the past 1 week. We have the fan mode. This is the state, as well as you can see the properties, the location, and the last service date. So the dashboard is a cumulative. It's a templated display wherein you can see all of the information as tiles so that you can easily understand and you can capture if anything goes wrong, if any wrong behavior is tracked. So that's about it with the basic overview of the Azure IoT. And I hope this small demo just gives you an idea of how powerful this entire tool can be at our disposal. If you have any doubts or any questions, feel free to drop them in the chat box. I shall be handing over control back to Mekla. So,
thank you, Aman. Any questions, please go ahead and type them, or you may ask the question. All right, so looks like we have no questions. So I request all the attendees if you can share your email addresses. It just helps us to share further communication about the webinars. And all our webinar recordings are available on our Cloud9 website under the respective event information. So please visit our site at cloud9infosystems.com. And coming to the Azure assessment, it is a Microsoft and a Cloud9 joint investment. This is a consulting service that is available for your organization, and depending on your company, it may be free, or you may use these consulting hours to get a roadmap to services like the Azure migration, SQL upgrade, BI, and analytics as well. If you're interested, please email us at c9sales@cloud9infosystems.com, or you can call us at 855-225-6839. Our next webinar will be on the November 14th, Wednesday, on the topic Exploring Azure Virtual Machines Scale Sets. Again, it's about exploring Azure Virtual Machine Scale Sets.